Example 1 pretty clearly was simply graph the stuff. You guys have done that. You did that when you were little. If they say to you, draw the graph of each equation, and they say x plus y is 7. Well, that one's super, super easy. You can easily say to yourself, well, let's find some values that'll work. And by the way, whenever you are simply using logic to try and figure these out, don't make the graphs super huge. Like, I wouldn't necessarily use 0 and 7. You could, but you might not want to. I would use maybe 3 and 4 and 4 and 3. But you could also use 0 and 7 and 7 and 0. Are you guys okay with how I came up with these numbers? These numbers, when added together, do give you 7. That's the whole point. And if I were to graph it, and there are negative values that would obviously work as well, but for our purposes right now, I'm just being simple about it. So I did 3 and 4, so over 3, up 1, 2, 3, 4. And I did 4, 3. And I'll do 7, 0. 1, 2, 3, 4, 5, 6, 7. That's 7, 0. Okay? Those points that I've just identified are solutions of the graph in question. 1, 2, 3, 4, 5, 6, 7. It would be way up there. But for our purposes, we'll just quit here. So anything found on this line would solve the solution, or the equation, x plus y equals 7. Okay? X plus y equals 7. That one's pretty simple, and they're not always quite that obvious, unfortunately. And again, you can solve if you like. So let's just do, here I've got another one just like this. Y minus 2x equals 6. Now this one's not quite as obvious. Y minus 2x equals 6. What if I made y a 0? 0 and then negative 2 times what will give me a 6? Yep. I'm a big fan of using 0 whenever possible. And what if I made x 0? 6. Very good. I now have 2 points, and with 2 points you can draw a graph. I only did 4 just so you could see what it would look like, but with 2 points you can draw a graph. So negative 3, 0, and 0, 6. So
Call Brands and Travis Harpster to the office, please.
So for homework, we need 2.
yeah. 1, 2, 3, 4, 5, 6. Shoot, I didn't go quite high enough. Okay, so here's negative 3, 0, and here's 0, 6. I have 2 solutions now drawn. Anything that falls on this line then should satisfy the equation y minus 2x equals 6. Okay? Y minus 2x equals 6. Okay. Example 3 continues what we're doing. It's not that much more difficult. But before I introduce that to you, I just want to show you that equations in this form, ax, some number times x, plus or minus some number times y, equals something. Anytime you see an equation given in this form, something x, something y, and a number, you're going to be graphing a line. Okay? This is a line. And any values that satisfy whatever the equation is will be on this line. So this one I have by and something x. It doesn't really matter what order they're written in. X first or y first. This form means you are graphing a line. All of the answers to the solution in this form will be on a single line. So far, so good? Now, if it's something squared, it's not a line. If it's x times y, it's not a line. It has to be x and y added together, or a negative, like this one here was a negative. That's fine as well. So here's my example 3. I want a better example than the one they gave us. Hold on. Ooh, here's one. 2x plus 3y plus 12 equals 0. The reason I'm bringing this one up right now is because if you notice, it looks a little bit different than this, doesn't it? It's got something x, something y, added to something equals something. Is there any way I can convert this equation and make it look more like that by moving something around? What can I do, Ben? Yep. 2x plus 3y equals negative 12. That is a negative 12. Now you have a graphable line, and you can solve, you can plug in points, whichever works for you. I would simply plug in points for this. X and y, especially since 2 and 3 are both factors of 12. So let's make x a 0. If x is 0, what must y be? Negative 4, bravo. And what if y is 0? What must x be? Negative 6, okay? I really love the plug in your 0 technique. I really feel like that's extremely helpful. Now this is going to be kind of a big graph.
Can we use like 1?
You can if you want. You can definitely use 1. What if x is 1? Will it work? You won't get a whole number. Yeah. I mean, if it's a factor, like if it's a multiple and you think, oh, well, I can think of this, yes. But don't make it hard on yourself. You can use whole numbers, integers, whenever possible. But if you did this, then you would end up with 3y equals negative 14 after you subtracted that over. And whatever 14 divided by 3 is, it's just a pain in the rump to graph that. Do you guys understand what she just brought up? How by plugging in something that doesn't exactly make this a whole number, you're just making your job harder. All right, so 0, negative 4, and negative 6, 0. So I'm basically down and left. And you don't have to draw the entire coordinate plane. I'm only going to draw the lower quadrant, quadrant 3. 0, negative 4, over 0, down negative 4, 1, 2, 3, 4. And over negative 6, down 0. 1, 2, 3, 4, 5, 6. Anything on that line should work. Okay, that would be the graph. And remember, there's an infinite number of points that could work. So I'm not going to be looking for the same points from everybody as long as the graph looks the same. That's example 3. I plugged in zeros and solved for the other ones. Just made my life easy. Okay. Graph in the coordinate plane, example 4. This seems to be the trickiest, and I don't know why, it just is. Graph in the coordinate plane. What if y is 4? That's the first one the book gives you. I'm going to give you one. What if y is 2? What if y is 2? That means for any x, y is always 2. So 0, 1, 2, I don't care. Pick a number, but what this is telling you is that y is always 2. So you can go right, left, whichever you want. I can go right, stay on 0. I can go right 1. I can go right 2.
Mrs. Meyer,
Yes,
can you send YJ up, please?
you bet.
Thank you.
But I know that my y is always a 2. So I did over 0 up 2, over 1 up 2, over 2 up 2. Notice that when the y value is always something, it's a horizontal line. Whatever the y is, if it's always the same thing, then you have a horizontal line. Now, go back to that equation for a minute, the whole ax plus by equals c. How does that fit in with that? Well, I want you to look at their solution that they have, and for a second, the equation y equals 4 can be written as 0x plus 1y is 4, which means I could say this, 0x plus 1y is 2. And if you got rid of the 0x, y is 2, which is exactly what that is. Okay? That's how this can translate into that. Now, what if the x value is always the same? I'll give you an x value, and it doesn't matter if it's fractional or a whole number. They give us a fraction, I'll do the same. I'll do a fractional x value, 3/2. That means no matter what the y is, x is always going to be 3/2. It doesn't matter what the y is, x is always 3/2. So that means your right movement is going to be to 1.5, and then you can go up or down to any y that you wish. There's 0, 1/2, 1.5. Here's 1, 1.5. Here's 2, 1.5, and so on. Okay, this is a graph of x being equal to 3/2 no matter what. The y value can change. You can go up or down, however you like. But the x value is always 3/2. To graph or to write that as ax plus by equals c, it would be x plus 0y is 3/2. X is 3/2. That's how you use that equation, and you can justify in your mind that this indeed does equal that because of that. Okay? That's what we're working on today.